In this question, it is given that the density of a newly discovered planet is twice that of Earth. The acceleration due to gravity at the surface of planet is equal to at the surface of Earth. If the radius of Earth is r, radius of that planet would be. So Rm is to find out the relation between these parameters. One is density of planet and acceleration due to gravity and the radius of Earth, radius. So we know the equation for acceleration due to gravity, that is gm divided by r square, but over here the relation is between g, mass and radius. But Rm is to find out the relation between g, density and radius, so this g can be written as g into this mass. We can write it as density into volume, because we know that density is mass divided by volume. So mass is nothing but density into volume, so instead of this mass we can write density into volume divided by r square. So g becomes g into density into volume. We can take it as 4 by 3 pi r cube divided by r square. So this r cube and this r square get cancelled. We'll get it as in this form: g is equal to g into density into 4 pi into r divided by 3. This is a value of acceleration due to gravity with respect to these parameters like density, radius. Now we can identify what about the relation between this radius and the other parameters, because I am writing it in terms of radius because in question they are asking to find out the value of radius. So we can write this r as equal to 3 into g divided by g into rho into 4 pi. So if there is a question related to this proportion, we can write by using this directly proportional, or from here you can write this r is directly proportional to g and inversely proportional to d. Now we can observe in this question. In question it is given that acceleration due to gravity on the surface is equal to acceleration due to gravity on the planet. So we are not changing the value of g, only we are changing the density. Density of newly discovered planet is twice that of Earth. So density of that planet is twice that of Earth. So we can write acceleration, we can write the density of that planet is basically 2 times of density of Earth. So over here only one parameter which is changing is density, as acceleration due to gravity is also same. We can write r is inversely proportional to density. So from here you can write that is radius of that planet divided by radius of Earth is going to be density of Earth divided by density of that planet. Now in question it is given that density of that planet is 2 times of density of Earth. So this density and this density get cancelled. So I'll get the ratio of radius of planet to radius of Earth as nothing but 2. So we can write the value of radius of that planet is radius of Earth divided by 2.